Hey everyone, and welcome back to PrepFusion. I'm Anish, and today we'll start the lecture 2 of linear algebra chapter. So this is the the second lecture of engineering mathematics course. In this lecture we'll study about determinants and their minors and cofactor, addition and multiplication of matrices and types of matrices. So basically we'll study about matrices. But before starting the lecture, I want to summarize quickly what happened in the previous lecture. So what happened in the previous lecture? First, we started with solving the linear equations. So like solving the linear equations we have been doing since childhood. We solved few linear equations and we tried to plot. First we understood what is a linear equation, okay, like which satisfy, like which is a straight line in 2D graph, which is a straight line, or what we can say where the order like equation is a 1 degree equation, okay, where the order is always one of the variables, okay, of all the variables. So those are known as my linear equations. Next, what we learned, we solved few equations through method of elimination, okay, and we got three types of solutions. One was the unique solution where they were crossing, the two lines were crossing exactly at one point, hence it has a unique solution. Only one point will satisfy two lines, okay, two equations. Here it was always true, 0 equals 0, so there it was always overlapping. So I forgot to write here, it is always overlapping in this case. Overlapping, okay, so this is always overlapping. Next, third type of solution we got was they were never overlapping, they were always parallel with each other, okay, and they will never cross because they were parallel with each other, but they were never overlapping, okay, they had some distance between them. So basically they will never cross each other or never cut each other, hence we had no solution. So I gave you like a tree diagram about when will solution exist and when will no solution exist, all those things, right? If solution exists, they are known as consistent set of equations, and if no solution exists, they are known as inconsistent set of equations. Then like we represented those in matrix. I taught you about what is a matrix. Then we represented the same equations in vector interpretation. So after we represent it in vector format, from there also we can understand whether we can get a unique solution or not. It's simple, like in physics what we used to do, add two vectors, right? That is what we are doing. We're trying to combine two vectors linearly, okay, with combination of numbers, real numbers, so that I can get my resultant vector as this 4 2. And in the first case, obviously I got only one combination was able to produce this 4 2, and here all, any combination, not all, any type of combination, if I pick one of the combination, like one value of x, then other value of y I will get, okay, will satisfy. Then again if I pick another value of x, another value of y also will satisfy, okay. So any type of combination was satisfying. So this was infinitely many solutions. Here no solution were satisfied because I was always lying in this line only, and obviously with the combination of these two I will never be able to produce this because this is not in the same line, right? This is somewhere else, and I am able to only move, I am able to get only resultant vector along this line, okay, that's why. So I had no solution, no combination satisfies this equation. So then I like taught you the basic theory, like what is known as a systems of equation, and then like bit of terminology, because gate questions will come with terminologies, so you have to understand the terminologies as well, because just knowing the concept is not good enough. They will play with terminologies, that is very important. So then I wrote standard matrix format, okay. I told you when there will be some solution, when there will be no solution, okay. Through there we understood that yeah, it is very important to study matrices because those will help us determine the nature of solutions of the linear equations. And like we know linear equations are very important because they are easy to solve, and like what we do, we convert non-linear equations into linear equations, okay, for our convenience, and then we solve those. So basically I was explaining the flow, so that's where we ended basically previously. So it took a lot of time on the previous lecture, so this lecture will also be a bit long, so hang on there and just be focus fully, okay. These are easy things, so I don't think like who have already studied 11th 12th very well, this will just, you can blaze by, you can 2x this, because these are easy things for you. If someone is from diploma, they can watch slowly, okay. If someone is very good with mathematics or linear algebra, they can 2x this, 2x and watch this, okay. So yeah, what is a determinant? Determinant of a matrix is a scalar value computed for a given square matrix, okay. It is some scalar value which is computed for a given square matrix. Linear algebra deals with the determinant. It is computed using the elements of square matrix. So yeah, linear algebra uses the determinant. It is like an operator, okay, and it is computed using the elements of square matrix, and it is used widely, okay. It is very important operator. So like how do we represent it? So basically determinant of determinant determinant of matrix, okay, basically it is like an operator, okay. A is equals to determinant of A equals to delta. So these are the signs, okay. These are the few signs through which you can understand that they are determinant, like it is talking about the determinant of the matrix A. So delta is also written over here, so they can represent determinant as delta also. So how do you compute the determinant? So for a 2 cross 2 matrix, like I know, like you already know this, for a 2 cross 2 matrix, okay, the determinant will be, if it is 2 cross 2 matrix, it is like, let's write the elements a11, a21, a22, okay. Now what we do, we just divide this into parts, okay, and what we do, a11 times this a22 minus a12 times a21. Now what does this actually physically mean? What does this actually physically mean? So let's understand this first. What does this physically mean? So like this was the formula for the determinant. So let me just make the axis of a 2D graph, okay, x and y, okay. So, and let me take the previous example. So what was the previous example? That this one, right? The first example, this one. And from here we find the determinant of whatever coefficient matrix we found out, right? So here we can write this in matrix format, simple only. So this is 1 minus 3, okay. Let me, okay, this will be a difficult, actually difficult to plot in the graph. What I will do, I will take something easier for you to visualize. So I will just change this equation a bit. What I will do, I will do this for us to easily understand things. So I can do minus x plus 0y equals to some value, whatever 2 you take, and then you take 0x plus y equals to minus 1, okay. So I am taking this equation just for visualization purpose, okay, just to visualize it very easily. So here what we'll do, we will again write this in the vector matrix format. So if I write this in the matrix format, this will be minus 1 0 0 1, and okay, just hold on a second. This will be simply, yeah, this will be x y equals to 2 comma minus 1, okay. This we can write. Now we can write them individually. How we can write them individually? So we can write them individually like this: minus 1 0 x plus 0 1 y equals to 2 comma 1. Now if I write this in the vector format and plot this in the graph, what I will get? So here I have one vector which is telling me minus 1 comma 0. So this is minus 1 comma 0. So minus 1 is in this direction, and 0 is like, we don't have any direction in the y, so we don't move along y axis. So this is minus 1 comma 0, okay. And now this is 0 comma 1, 0 comma 1. That means I'm not moving along x axis, I'm moving along y axis in positive 1 direction. Zero comma 1, okay. Now what are we doing actually? So when we do this, right, we are basically finding the area. So if you observe this carefully, whatever value you will get after the determinant, you will see that you're getting a area here. So, or you're doing the cross product and taking the magnitude. If you recall your vector algebra days, like when we studied 11 12, so if you do the cross product of these two vectors and just find the magnitude of that cross product, what you'll get? You'll get the area. So if you remember that the area of a parallelogram was something AB sine theta, something like that, right? The angle between them. So here it's same only. AB sine theta is sine 90 is 1, so it will be A cross B. Okay, A times B basically. So here the determinant will be, if I write the determinant, okay, like, or the area of this thing, area, what will be the area of this? What is the area of two vectors? It is the basically magnitude of A cross B, magnitude of A cross B simply. So what is our A in this case? If you observe this carefully, our A is what? This one, right? This is our A. So I will write this as A, and this as A cap, A bar, and this as B bar. Okay, so this will be A11 I plus A, so this is A vector, right? This is A21 J cap cross A12 I plus A22 J. Okay, so basically this is the B vector and this is the A vector. Okay, I'm just writing, representing in terms of I comma J. So basically I should write here I comma J, else you will get confused, like what is this X and Y. So this is the, like, the J direction, okay, and this is the I direction. Okay, J I J K. So I should replace the other, like the previous ones also, else you will get really confused, like this X Y you will get confused with. Simply I and J direction, which we have been doing since childhood. So yeah, this is the case. Now let me, yeah, now what is the cross product? So if you have studied vector algebra, well and good. If you haven't, don't worry, I'll teach you all this. So basically if you do the cross product, obviously I cross I is 0, because like, what is the angle between I cap? 0, right? So A11 into A22 into sine 0 is 0, so that's why it is 0 only. So first will be 0, then A11 into A22. Now what is this? I cross J is K cap only, so it is K cap. So anyways we are interested in the magnitude, so we won't care about that. So let me write this just, so this will be I cross J, so this will be A11 A22, okay, and sine 90. Okay, we're interested in the magnitude here. Okay, so basically sine 90, and this is in the K cap direction. I cross J is K cap. Okay, now this again J cross I, now this is minus sine 90, so this will be minus K cap, right? So plus A21, like J cross I, is minus K. If you don't know, don't worry, we'll study this in vector algebra, don't worry, I will visualize you there. Okay, we just don't have time for everything right now. So this will be minus K cap, and then again it is plus 0, because again J cross J is 0 itself, because sine 0 is 0. So we are only interested in the magnitude, so this will be magnitude of, I can take this common, so minus A21 A12 and K. Okay, K cap. So magnitude of K cap is obviously 1. Okay, so the answer will be A11 A12 minus A21 A12, which is the determinant of A. Okay, so basically in 2D it represents the area, determinant represents the area. Okay, so I can write for n equals to 2. N equals to 2 means a, like this order. N is order of matrix. Okay, the determinant, just hold on a second, everything is recording, right? Yeah, fine. Just the determinant represents area between the two column vectors. So they are column vectors, right? So these are column, these are not row vectors, column vectors. Area between, so just hold on a second, area between two column vectors. These are not that important actually. Okay, like I can just simply see with the formula of what is determined and that's it. But sometimes visually understanding this is good. Okay, else not that important. You can like skip this also. Okay, no worries. But if in gate some good question comes from the area or something, so it is good, right? It can happen. Now let's come to the 3x3 matrix. So I will tell you how to find the determinant for a 3x3 matrix. Then I will say you the general procedure for finding the determinant for any n cross n matrix. So now if my A matrix is 3x3, okay, so I'll just what I will do is just copy this matrix. I had this matrix, right? Okay, I'll just write this then. I have a 3x3 matrix, A11, A12, A13, A21, A22, A23, A33. Okay, so now basically how to find the determinant of this, we will break this down into smaller 2x2 determinants. Okay, how we will do that? So basically we can write, okay, either we can open up through anything, but we have to open through one row or one column only. Okay, so open the determinant through one column or row. Okay, so how will you open the determinant? So through one column or row, what do you mean? Either you can open through this, either you can open through this, or you can open through this column, you can open through this column or this row or this row. Okay, so let me open through this. Let me open through this. So if I open through this, what does it mean? So first I will write this, like I'm opening through this second row, I will write this element of this second row, then I will neglect the row and column of this element basically. Okay, row and column. So what is left? I have 4 elements left, right? I will write those just sequentially as they are written over here. Okay, there is obviously one thing missing. I will tell you. Just let me first complete this. A33. So this is the first part. Now again I will take the second element of this row. I'm opening about the row. Okay, okay, through spelling is wrong, apologies. Okay, now I'm opening through like I'm opening for this second element, so I will write this second element. Then again I will ignore this column of this element and the row of this element. Obviously row is always same, but the column changes now as I'm opening to the row. So what elements are left? A11, A13, A31, A33. So we write those. A11, A13, A31, A33. Okay, now what next? Next is, let me reduce the size of these. Okay, I will just do the final thing later on. Next is this third element. So in this third element, what I will do? Again, I will ignore the column and the row. Row is same, column is different. So I will ignore this column. So elements are left are this: A11, A12, A23, A11, A12, A31, A32. Okay, now what thing is missing? Obviously I have to combine these things, right? Combine these things. How will I combine these things? So that also I will explain. Now for combining, right? For combining, this is one shortcut, but obviously the full method I will tell you in the next slide. But what is the shortcut? So the shortcut is, first you start with plus, then go plus minus plus, then you go in this direction. So this will be plus minus plus, then again like you go in this zigzag direction, right? Not in the simple here then here, no, there is a breakage. So you go in the continuous direction, plus minus minus plus minus. Okay, or how you can understand? You can understand that there will be always one sign change. Okay, if you go along a row or a column. So if you go along this, okay, sorry, I made a mistake over here. Plus minus plus, okay, this will be minus, sorry, that is where I'm making the mistake. This will be minus plus minus plus minus plus. As I was saying, that there will be always one sign change if you go along a row or along a column. So you see, one sign change, again one sign change, again one sign change. So either you write along the row, fine, you start with plus. Obviously we all of us start with positivity, then some negativity comes up, so that obviously breaks the equation. Okay, then obviously this plus this becomes minus. Okay, here one sign change and then again plus. So like that also you can derive, like everywhere I go there will be at least one sign change. Okay, or you can remember this zigzag pattern: plus minus plus minus plus minus plus minus plus. Or I will tell you obviously how does this plus minus comes up. I will tell you just in the next slide. Like how does this come up? It comes up sign convention, it's basically minus 1 I plus j. Okay, now what is I is the row of that particular element and j is the column of that particular element, and 1 raised to power that. So basically you can see that it is 1 plus 1, so minus 1 to the power 2 is 1 only, then 1 plus 2, then minus 1 to the power 3 is minus 1 only. Okay, so here what will happen? So what is the, like, either you do this convention or you can do from here also. It is I comma j, so 2 comma 1, so 2 plus 1 is 3, minus 1 to the power 3 is minus 1, so this will be minus 1. So or here also you can see, here we have a negative sign over here, so like either way you can cross verify. So this will be minus. Okay, let me use another color. This will be minus. And what about a to 2? So 2 plus 2 is 4, minus 1 raised to power 4 is 1, or you can cross verify. Yeah, it is plus over here, so it is plus. Basically 1 means plus 1, so like plus 1 times anything is same only. Then again 2 3, so 2 3, 2 plus 3 is 5, so minus 1 raised to power 5 is minus 1, so this will be minus. Or what you can do, you can remember the even odd funda. So basically for even it will be plus, for odd it will be minus, basically after adding them up. So like that is also very simple. So I will write everything, whatever suits you, you use that. Whatever suits you, you use that. Even, and odd, is minus. Okay, even and odd is minus. Okay, so yeah, this is what like basically how you solve a 3 crossing matrix. So I will also explain you like what does the determinant of a 3 cross 3 matrix means. So here basically I have a 3 crossing matrix and I have drawn the vector of each of them. So if I draw the vector of this 1 comma 0 comma 0, so this will be again I cap j cap k cap, sorry, I j and k. Okay, so 1 comma 0 comma 0 means only I cap. So I cap is in this direction and this is the 1 unit. Okay, 1 unit of the I cap. So like if the drawing isn't to scale, please excuse me. Okay, but like just try to understand the भावनाओं को समझो, मतलब क्या हो रहा है यहाँ पे, ठीक है. तो इफ यू डिडंट अंडरस्टैंड हिंदी दैट्स फाइन ऑल्सो, बिकॉज आई डिडंट से एनीथिंग मच. तो लाइक ओके, फिर हिंदी में बहते बहते हिंदी में ही बोल दूंगा, फिर गलती हो जाएगी. देन what will happen here, this is 1 0 0, then next is 0 1 0, which is like only j cap, right? So j cap is in this direction and it is like this. Okay, this is 0 1 0. Okay, next I have k cap, so it is in this direction obviously. Let me use so 0 0 1. Okay, so this is k cap, I cap, j cap. Okay, so now what are we doing? Basically again we're doing the same thing only. We're like doing the cross product of all these things and then finding the volume basically. So like if you compute this, right, what you will get the volume. So for a 3 crossing matrix we're computing the volume over here. So here if I break this down, right, what I will get, one, like I'm breaking this down along this first row. Okay, 1 times, so I will write first row, so this is 1 0 0 1, then everything else is minus 0 times anything, so I don't care about that. Okay, but still I will write it 0. This will be so I'm taking this one. Okay, I'm sorry, I'm taking this one, so this will be 0 0 0 1, 0 0 0 1, then plus 0 times I'm taking this one, this will be 0 1 0 0, 0 1 0 0. It doesn't matter because you will understand these are zeros only. So what are we getting? We are getting it as 1 only, because 1 minus 0 is 1 only, so this is 1. So here also we can observe that the volume of this is 1 because this is a cube of unit length. So yeah, everywhere length is unit 1, so it will be 1. So if you take a cube of unit 2, it will be so length 2, it will be 8, so you will get the volume as 8. So for a 3 cross 3 matrix, determinant represents the volume. So yeah, just want to give you a visual picture of this. Okay, nothing like too fancy, just want to give you like what is actually determinant doing all those things. It is just simply an operator with which we can find many things. Okay, I will tell you, because here, right, it tells us about the dependency of these lines. How much area does these two lines cover, these two column vectors cover? So there, if they don't cover any area, then there can be few possibilities. So I will go to that, slowly. Okay, so just try to think in that domain, like if they are not covering any area, they are in the like same length only, same line only. Okay, how much area are they covering? Okay, or they are directly in the opposite direction. Okay, all those things. So yeah, basically that is what I meant. So here in this case, the determinant represents volume for n equals to 3. Between two column vectors. Okay, so yeah, basically just wanted to give you a visual picture. Now let's like read few key points about determinants. So determinant doesn't exist for a non-square matrix. This is the first very important. No, for non-square matrix, determinant won't exist. So a matrix like this, okay, 1 2 3 4. Okay, let me write this properly. 1 2 3 4 5 6. Determinant does not exist, so we can't find the determinant of this matrix. Just hold on a second, I should write this like this. We can't find the determinant. Okay, determinant not possible. Now determinant only exists for a square matrix. Up until now we have been finding the determinant for only square matrices. Also, for n cross n matrix, the determinant will have a maximum of n factorial terms after expansion. What do we mean by this? So basically, for 2 cross 2 matrix, what did we saw? We saw 2 terms, right? 2 terms after expansion. So it was a 2 cross 2 matrix. So 2 factorial is 2 only. So 2 terms in expansion. So here I can write, let me take another color. Okay, 2 terms in expansion. Now if for a 3 cross 3 matrix, how many terms are we getting? So here what we observe is, basically you might say that, sir, we are getting only 3 terms, it should be 3 factorial, right? 6, but here we are getting only 3 terms, but in between also there is determinant, right? So if I expand this, how many terms I will get? 2 terms. So this overall thing will give me 2 terms, this overall will give me 2 terms, this overall will give me 2 terms, so total 6 terms. So here I can write 2 terms and 2 terms. Okay, total 6 terms. So 6 terms after expansion. So maximum term I can get n factorial. So if you remember this, well and good. If you don't, just try to derive. You can derive this. Okay, I also don't remember. I will tell you honestly that I also sometimes I basically forget these things. So either write in your short notes, or try to derive. Okay, from through this, like for 2 cos 2 you are seeing 2 terms in the expansion. For 3 cos 3 you will see 6 terms in the expansion, and from there you will understand, yes, it is something like a fact, it is following a factorial rule. So 2 factorial is 2, 3 factorial is 6, like that something will come up in your brain. Okay, or you write in the short notes and revise, because gate this may not be asked. Okay, but in other examinations, engineering services examinations and other types of examinations, this may be asked. Okay, so yeah, this was about the key point. Okay, now let's do few questions. So basically we have to find the determinant of these 3 coefficient matrices. Okay, I was copying this, but obviously like plotting that in the graph will be a bit hectic for me. That's why I took the simple example. I hope you understand. You can, if you have time, you plot these things in the graph. Okay, and then check graphically how much area each of them are covering, and from there you might get some idea, some knowledge about the determinant. Okay, what does determinant say to us? So yeah, let's just copy this equation. Simply what we can do, I will just do this a bit fast manner, because these we have done multiple times. Okay, just we'll write the coefficient matrix here. So coefficient matrix, they are asking just the coefficient matrices, so I will write the coefficient matrix. Okay, A will be equals to 1 minus 3 3 1. Okay, so determinant of A will be equals to what? Determinant of A will be 1 times 1 minus 3 times 3. Okay, so it is minus 9, and minus 9 is ahead of it, so it will be plus 10. So we are getting determinant as plus 10. Okay, we will understand what does this plus 10 actually represent. So this is for the A part. Let's similarly do for the B part. Just doing the coefficient matrix. What is the coefficient matrix? Coefficient matrix are the coefficient of this xy variables. So yeah, now again here let me name this as A1. Okay, and let me name this as A2. So this will be 1 minus 3 minus 2 6. So here the determinant of A2 will be 6. 1 times 6 minus of minus 2 into minus 3, so it will be simply 0. Okay, something interesting is happening here. Next, for the C case. For the C case, everything is recording, right? Sometimes like get freaked out if nothing is recording. So again, writing the coefficient matrix A3. It is 1 minus 3 minus 1 and 3. So again, if we find the determinant, what will this be? It will be simply 1 times 3 minus 3 times minus 1, which is equal to 3, again 0. So what we are observing is we are getting 0 2 times, okay, and here we got some non-zero value. So what was this case? This was for the unique solution case. Unique solution, right? If you recall correctly, unique solution. Here what was the case for, like how were my solutions? In this case they were infinite, okay, infinite solutions, or overlapping, if you recall. And in this case I had no solutions, okay, I had no solution. So basically I've already written it here that if I have n linear equations and my determinant delta is not equal to 0, then I can say it will have a unique solution. It will have a unique solution, okay. But if my delta is 0, then I have to further check. Whether it will have infinite number of solutions or no finite solutions. So this I am sure about this. If I get the determinant non-zero, just hold on a second. Let me take some different color. I'm trying to find a different color. I'm sure short that if my determinant is not equal to 0, okay, determinant is not equal to 0, then I will always get a unique solution, okay. And if my determinant is 0, then I have to further check further, okay. Hence check further, okay. Like what do I need to check further? That we'll understand. Like from here, two things can happen, right? Either determinant is equal to 0 or not equal to 0. If it is not equal to 0, then I can definitely say it is unique solution. If it is equals to 0, I don't know, I have to further check. What do I have to check? I have to check the rank, okay. So rank concept will come much later, but for now I'm just giving you a glimpse of things what will come, okay. So infinite number of solution, number of solutions here. So this was the thing about the determinants. Now I want to come to the minors and cofactors. So basically I told you, right, I will give you a formal method to calculate the determinant, which we'll never use, okay, but still we have to teach you all this, so we will, okay. So basically minors and cofactors are also basically operators and terminology. So they are also operators and terminology. So basically don't worry about them if you don't understand, okay. So basically they are also operators. Okay, so if I have a given matrix A equals to Aij, okay, and I is varying from 1 to n and j is varying from 1 to n, and A is A11, A12, A23, and like the 3 crossing matrix, okay. And let me name the column. So this is the C1 column, C2 and C3, and this is the row 1 column, sorry, row 1, not the column. So this is row 1, row 2 and row 3, okay, row 1, row 2 and row 3. Now basically like let's find the minor. So through one example we understand. So again, like this is the first column, right? So let's find the minor corresponding to element A12, okay. So from there I will obviously say with the formula, but let's do it with one example. So already we have been doing this, but still. So minor, let me write this, minor, let me check if I'm well within the camera or not. Minor of corresponding A12. So what will the minor? So we write our minor like this, M I comma j. So I will write M12, okay, and it will be simply the 2 cross 2 determinant in this case, because our this matrix is 3 cross 3. So A12, what is A12? A12 is this element, A12 is this element. So if A12, what is 1? 1 is the first row, okay, first row, and the second, let me write 1 2 3 here, 1 2 3, second column. So what we'll do, we'll just ignore the first row and the second column, okay, and we'll take the other 4 elements as it is, as it is. So it will be simply 4 6 7 9. Basically it is a determinant of those 4 elements, and here in this case it is 4 times 9, which is 36, minus 7 times 6, which is 42. Okay, so this will be this is 9, right? Yeah, 4 times 9 minus 7 times 6, so which is minus 6. Okay, so minor is minus 6, it doesn't signify anything, but that is fine. Now I told you what is a minor is. So minor is basically the determinant. I will tell you like what is minor for a 3 cross 3 also, okay, like for a 4 cross 4 matrix also I will tell you that, okay, don't worry. But for the 3 cross 3 I hope you understood like this is a minor. Let's do it for a 4 cross 4 matrix. So I will just, what I will do is I will just copy this thing totally, and I will make it 4 cross 4, and from there also we will understand what is a minor for a 4 cross 4 matrix, and through there you will be able to grasp this thing. So if A is my 4 cross 4 matrix, now one row and one column has been increased. So basically let me write this as 10 11 12 13, anything I'm writing, anything just out of my head, 14 15 and 16. Now what will be the minor corresponding to A12 element? So now, right now, so again I have to totally cancel all the elements on that column and on that row. So again I will copy this thing, okay, let me color this thing actually. And this is like not 3 cross 3 anymore, this is 4 cross 4. Now things have changed. Now we have more number of elements. As you can see, we have to write as it is, whatever is present, excluding the row and the column of that particular element. So basically what do we see? We see a 3 cross 3 matrix right now. So we have to compute a 3 cross 3 determinant instead of a 2 cross 2. So 1 will obviously not be included. 4. So I will take this row, this column, and this column. So 4 7 and 13 6 9 and 15 11 12 and 16. So yeah, 11 12 and 16. So now you compute the determinant for this, and that will be your minor. So let us compute for this. So basically you can use that simple thing, 4 times, break it down into chunks. Okay, so for this, for like first few examples I will break it down into chunks. If someone doesn't understand, else you can 2x this, right? You can 2x this, you can skip this part. Minus 6 7 12 13 16 plus 11 7 9 13 15. This is 15 only, right? And this is also 15. No, this is, yeah, this is 15 only. This, okay, fine. So what will be the determinant? So this is 4 times 9 times 16 minus 15 times 12. So I'll just use the calculator because I'm lazy right now, else I would have done it like properly. So You can do this brain like you in your head also, mind calculation also. 9 times 12, 9 times 16 minus 15 times 12, which is minus 36. Okay, and then it is minus 6. 7 times 16 minus 15 times 12, it is minus 68. Then 7 times 15 minus 9 times 13, so it is 11 times minus 12. Okay, so let me compute this further. Okay, let me compute this further. So this is 4 times 36 and then plus 6 times 68, then minus 11 times 12, basically 132. So minor for this will be 132. Okay, so yeah, this is how you compute the minor. Okay, just you can compute for other elements also. So now what is a cofactor? What is a cofactor? So cofactor will basically let me, it is just simple. If you understood the minor, cofactor is just in 1 second you will find cofactor. So what is a cofactor? So cofactor, right here, cofactor. What is cofactor? So cofactor equals to simply minus 1 I comma j. Okay, let me just write the formal definition of cofactor. Okay, let me write the formal definition of cofactor. I comma j, I comma j, minus 1 I plus j. I and j are the row and column. So where I row and j is the column. Already know this, but still column, right? I plus j into the m I comma j, basically the minor corresponding to element. So I will write not in this notation. I'll just directly write this notation. Let me reduce the size. So this is the case. Now basically what we do, like for let's say like I need the cofactor of the this a12 element. So for what do I write? I write like this: c12 equals to minus 1 1 plus 2, like row and column, into the minor. What is the minor? Minor is 132. Or I can write, for now I can write m12, which is equals to minus 1 whole cube into 132. Again this is odd power, so this will be negative only, 132 only. So cofactor will be minus a12. So what do? First you find the element corresponding to which you have to find, like if they ask you to find the cofactor for this particular matrix. So first you find the element. Okay, you find the element, okay, about which you have to find the cofactor. Then you find the minor. Okay, then you do simple this odd even thing, right? If it is in odd place, you will like do it, or you will multiply minus 1. If it is in even place, you will multiply only plus 1. You will not change the sign basically. So then you will be able to find the cofactor. So there are 3 steps for finding the cofactor basically. Okay, so yeah, this is basically it for the cofactor thing. Okay, nothing fancy or something. So like you already know this. If you don't, like these are just a few operators that you have to know. Like these are used to obviously compute the determinants, basically compute the determinants. So basically how do you compute the determinants? So if you want to compute the determinant, right, if you want to compute the determinant, so let's say I have this matrix, right? A n cross n matrix, So how can I compute the determinant of this? So the determinant of this, let me just first write this here. Okay, let me take this 3 cross 3 matrix itself. So what will be the determinant? I've already told you how to like compute the determinant, but in formal terms, what will be the determinant? Determinant will be simply, if I break this down, open this through the first row. So if I open this through the first row, I will write A11 and multiply the cofactor corresponding to this element, which is C11, and C11 we already know how to compute. Okay, plus I will just simply add those two because cofactor will take care of the signs individually. Then A12 into C12 plus A13 into C13. Okay, so they are taking care of the signs individually, A11, A12 and A13. Okay, so this is how you can compute the determinant, or you can write, you can break, like open through this column also, you can open through this column also, doesn't matter, but you have to write the cofactor corresponding to that only. So this will be A12, like I'm breaking this down throughout the second column. Okay, then A22 into C2, just hold on a second, yeah, C22 plus A32 into C32. Okay, so either way you break it down. Okay, yeah, you break it down through rows or you break it down through columns, it doesn't matter. Okay, you can break it down through either of these things. Okay, so yeah, this is about the cofactor. So if let's say it is 4 cross 4, then you will break it down through the whole row, because you will go A11 into C11, A12 into C12 plus A13 into C13 plus another extra term A14 into C14. So yeah, that is basically how you compute the determinant. Okay, so yeah, now like just basic simple things only, you have to compute the determinant. So we'll compute this pretty quickly. Okay, so like let's compute the first one. So how to compute the first one? What I will observe is I will find in which row or column has the maximum number of zeros. So if it has maximum number of zeros, I don't have to find the cofactors for those, because the elements are coming in the multiplication sign. If they're 0, then it doesn't matter, zeros multiplied by something is 0 itself, so I won't have to compute the cofactor for that one. So 0 0 I have, so in this third row it has 2 zeros, so I will open this determinant about the third row. Okay, because I have to find the maximum number of zeros. Okay, so if I open this about the third row, then what will happen? Basically 0 times anything which is C31 plus, now what is this, like I will obviously write 1 times the C32 plus 0 times the C33. Okay, now what is C32? Basically C32 is basically minus 1, not minus 1, sorry, is minus 1 whole to the power 3 plus 2, which is basically odd, so it will be minus 1 into M32, which is equals to this minus. So I'm going slow for now. Okay, next few examples I will go fast. So again I will write the simple matrix. So M12 is simply minus 1 into this matrix 1 3. I will write this according to the sequence 3 1. So this will be minus 1 into 1 minus 9. So this is minus 8. So this will become plus 8. So my answer will be first option, like first answer will be determinant of A equals to 8 itself. Now let's solve for the second case. So again I'm observing that here like in the second row there are maximum number of zeros, or also one thing I'm observing is the rows are same, just the second and the third row are interchanged in this case. So does it have any relation with the previous determinant? Let's see that. So let me just copy this. So this will be basically, so if I want to find the determinant, right, I will open about the second row this time. Open about the second row this time. If I open up the second row, so this will be simply, now I will go fast. I will go do this plus minus plus minus plus minus. So this is plus only, so this will be plus 1. Now I will, what I will do, I will just ignore this row 1 column. So I will be left with this only, right? I will be left with this 1 3, then 3 1. So this will be 1 minus 9, which is minus 8. So what I am observing is I am getting minus 8 over here, and previously I was getting plus 8. So obviously there is some relationship. There is some, everywhere there is some relationship, right? So, but like in your life there isn't. Don't worry, there will be also. Just study now, okay? And soon like you will also have fun. So yeah, don't mind anything if you are in already in relationship, okay? So we have to keep the mood light sometimes. So yeah, minus 8. Next, about the third case. Third case. So let me just, there is no relation between the previous previous matrices. Previous matrices. Let me just copy and paste this. So here in this case, what will happen? So basically this will be, if I want to break this down about this row, let's break this down about this row. If I break this down about this row, what will happen? 1. So I will do this plus minus plus 1 times 8. I'm not just showing you now, I'm doing this directly now. Minus 2 7 9 2 6 plus 3 7 8 2 4. Okay, so this is simply 48 minus 36 minus 2 times 42 minus 18 plus 3 28 minus 16, which is 12. So basically this is, which is 12 here, so it is 12 here minus 2 times 18 is getting subtracted here. If you subtract 20, it is 20 to 24. 2 times 24 plus 36. What do you observe? We get 0 over here. So is there any peculiar thing about this matrix, that the determinant of this matrix we get 0? Is there any peculiar thing? So if you like observe this correctly, what you will observe is, if I do one thing, that I multiply 2 with this row, I am getting the same thing as the third row. Okay, if I multiply 2 with this row, I am getting the same thing as the third row. So basically the rows are linearly dependent. So here multiply with this 2 times, and this is the same as the third row. So here what statement can I write? I can write is, rows are linearly dependent. Okay, so if rows are linearly dependent, that means that the determinant will be 0. If rows or column are linearly dependent, then the determinant of that matrix will be 0. Okay, so yeah, that is one thing. And what was the fourth question? Okay, we have 4 questions also. Again, right, you can compute this directly. These are, okay, is this the same or not? Okay, this is not the same. Okay, this is almost like this, but there is a twist in this. What is the twist? I will show you, but let's just find the determinant for this first. So like I have to find the determinant, so I will just directly write the determinant here. So I'm opening about the third column. Okay, but before that, obviously let me mark the signs. Plus minus minus plus minus plus minus plus. So 0 0 is gone anyway, so this will be only important to us. So minus 1 times this 1 yeah, no, sorry, 1 not 1 0 1 3 then 3 1. So this is what we are getting, minus 1 into 1 minus 9, which is again 8. We are getting 8 again. We are getting again 8. So if you are getting again 8, what does that mean? That means like previous case, in the first case we got 8. Okay, is there some similarity with this? So it is like let me name this as A14. Okay, A1, or let me name this as A4. Okay, let me name these things, else we'll get confused. Let me name this as A2. Let me name this as A3, and let me name this as A1. Okay, so if I name this as A1, so determinant of A1 is 8 and determinant of A4 is also 8. What does it mean? If we observe one thing, if we know already this, that A1 is equals to A4 transpose. What does transpose means? Transpose means, so AT is basically rows and columns of A matrix are interchange. Rows and columns of A matrix are interchange. Basically, what is happening over here? I becomes J and J becomes I. So what are we doing is Aij equals to, like we're exchanging Aij and Aji. Okay, that is what we're doing. So basically what we're doing is, like if I take one example, 1 2 3 4 5 6 7 8 9, this is A. Okay, if this is A, what will be the A transpose? Just hold on a second, let me, yeah, this is fine. What will be the A transpose? So A transpose is simply, I will interchange the rows and columns. So this is on the diagonal element itself, so this won't get interchanged. So I will write, you can write like this. So this is a column, right? So I will form this as a row. So this is the first column, so I will write this as the first row, 1 4 7. Then second column is this 2 5 8, so I will write this as the second row, 2 5 8. And third column is 3 6 9, I will write this as the third row, 3 6 9. Okay, so this is my A transpose basically. So I just interchange the rows or column, or as I explained there, Aiji will be Aij. You just see right here, what is it? It is A2, 1. So this 4 goes to here. What is it? What is the element here? It is A1, 2. So 2, 1 gets simply swapped, exchange 1, 2. So this is what my this A transpose will be. But what is the important thing to note here is that the determinant of my A will be equals to the determinant of my A transpose. The determinant won't change. Determinant will remain same even if we apply the transpose operation. Why is this the case? Because like intuitively what you can understand is, where we can open about any column, any row, so it doesn't matter if you open about column or row, so it doesn't matter. So yeah, that's why it's same only. So let's take the fifth example. So this is okay, sorry, this is interesting actually. Here 3 is getting multiplied over here. Now if 3 is getting multiplied over here, right, if 3 is getting multiplied, that means 3 is getting multiplied to all of this element. Do keep this in mind. Okay, if in front of some matrix some scalar is written, it will be multiplied to all of the elements. Why also I will explain. Okay, I will explain in later slides of this video. So basically determinant will be 3 6 9 9 6 3 0 3 0. Okay, we have to find the determinant for this. Now if I find the determinant for this, again I will open through this last row. So again, if I just do this plus minus plus minus plus minus plus minus plus, as I have the maximum number of zeros over here. So if I open through this last row, this will be minus 3 times this 3, like this is gone, so 3 3 and 9 9. So 3 times 3 minus 9 times 9, minus 3 into 9 minus 72, so sorry, not 81, which is minus 72. Okay, now how can we write it? So basically this is 3 times 72. Okay, so how else can I write it? I can write 3 times 8 into 9, which is equals to 3 cube times 8. Now as we can observe one thing, that this 3 is common, 3 is very common to us because 3 was in front of this, that's why this 3 came, and 8 is what? 8 is the determinant of this previous matrix. Oh, what, when we didn't have any 3, so this was the A, right? This was the previous matrix. Okay, and if you multiply 3 with this matrix, then the determinant gets 3 cubed. Where does this cube come from? Cube comes from this order of the matrix. This is a 3 cross 3 matrix, right? So if this is a 3 cross 3 matrix, the power will be represented by this cube. Okay, and the multiplication term will come here. Okay, and obviously the previous determinant, okay, previous determinant will obviously remain, so some property of matrix will remain. So all this I have explained in this key points. Okay, explained in this key points. So if two rows or two columns of a determinant are interchanged, then the sign of the determinant changes, which we have proved in the second example, which is interchanged either two rows or two columns. We saw that the sign got interchanged. Obviously determinant magnitude will remain same, but the sign will get interchanged. If any two rows or two columns are proportional, then determinant of the matrix will be 0. Okay, proportional or identical you can say. Okay, so they will be 0, as we proved in the third example. If all the elements of any row or column are 0, then also determinant will be 0, because elements come, right? Elements come in the determinant formula. So if elements themselves are all 0, then obviously the determinant will be 0. Then next, for a n cross n matrix, the determinant will have maximum of n factorial terms after expansion. Like I already told this in the previous like their previous key point. So here also again this is repeated. If 3 rows or 3 columns, okay, I should remove this point actually then. What did I write in the previous key point, if I recall correctly? Yeah, fine. So here, if 3 rows or 3 columns of a matrix are interchanged, then sign of determinant remains unchanged. Now if 2 rows or 2 columns are interchanged, sign changes, but the 3 rows or 3 columns are interchanged, then sign remains unchanged. Why? Because you did one swipe, then again you did another swipe. So 3 rows were interchanged. Okay, in total, one swipe got you one negation sign change, then another swap got you another sign change. So overall you had no sign change. Let's say you are initially plus, then you went to minus, then again you did another sign change, then totally you went to again plus. So it wouldn't matter. So what I am trying to explain, so like let's say like for 2 cross 2 only, let me explain for 3 crossing only. So I should copy this 3 cross 3 matrix. Yeah, this one, right? Now what can I do? I can find the determinant. Okay, now if I write the determinant like this, I will again copy and paste this basically. Three cross 3. Okay, so now if I interchange the sign, like now if I swap these two rows, so what I will do is just copy this. Okay, and let me paste this. and swap these two rows. If I swap these two rows, let me name this as b determinant, which will be equals to minus of a. Okay, again if I swap, let me copy this. Again what I will do, I will swap the third and the second row. Okay, you can swap columns also, doesn't matter. Third and second row. So let me name this as C matrix. So determinant is C this time. So again if I swap, this will be again another minus of a. So overall this will become plus of a only. That is what I was trying to explain. So overall it will become plus only. So if you do 3 interchanges, exchanges, it won't matter, the sign won't change. Okay, and another important point is if the determinant of a matrix is 0, then it is called a singular matrix. This is terminology. Okay, terminology, nothing else. And this singular matrix is very important. So as we told, right, if we get a determinant 0, then it can have either no solution or infinite solution. So if the matrix is a singular matrix, then it can have either no solution or infinite solution. So this means the determinant of A or delta equals to 0. So very important. If a matrix, they have told you that the matrix is a singular matrix, then it can have no solution or infinite solution. Okay, it can't have unique solution. That is one thing. And other thing, what I've told you, that few other things that you have to keep in mind is that your B, if B equals to A transpose, then determinant will not change. Determinant of B will be equals to determinant of A. It won't matter. Okay, and another key point, like just these are key points, you have to write this in your short notes if you tend to forget, but these are very simple points. Now if B equals to some scalar k times A, where k is some scalar real number, okay, then you, let me use some other color. Then your determinant of B will be equals to k raised to power n into A, where n is basically the size or order of the matrix. Size slash order. Okay, n is basically the size slash order of the matrix. Okay, and another property we have, I will talk about another property. If we have some matrix C, okay, you can derive it for yourself. We don't obviously have time to derive everything. C equals to A times B, which is matrix multiplication, which I haven't taught you yet. Just I will teach you in the next lecture, because this lecture has already gone long. I won't be able to get a chance to teach you, but don't worry. If you don't know matrix multiplication, it's fine. If you know, then also it's fine. So if we multiply two matrices, then the determinant, what will be the determinant? Determinant will be simply the multiplication of the two individual determinants. So I will write this like this: AB equals to determinant of A times determinant of B. We can write this like this. Okay, so yeah, these are the cases. Also, another important point, I haven't taught you inverses yet, but we will obviously learn about this. If some matrix B is equal to the inverse of the A matrix, then what will be the determinant? Determinant of B will be equals to determinant of A inverse, which is equals to 1 by determinant of A itself. Okay, if you don't understand, don't worry, we will learn about inverses, there we'll understand. So A inverse is basically some matrix which is the inverse of A. Okay, don't worry, we'll understand this if you don't know about the inverses. Okay, so basically that's it for this lecture. Basically we couldn't do the addition of matrices and multiplication of matrices. In the next lecture we'll try to cover up those. So like try to revise everything and recall everything whatever you have learned, and obviously I will do more questions in the next lecture. Okay, we'll do more questions and from there all our concepts will get crystal clear. So yeah, I hope you like this lecture. Thank you for watching, and I will see you in the next lecture.